So last time we discussed different kinds of chemical reactions, and we also did some balancing of chemical reactions. So nakita na natin doon yung importance ng pagbabalanse ng reactions using coefficient para ma-meet natin yung law of conservation of mass. So today we're going to continue our discussion with stoichiometry. So what is stoichiometry? It is the quantitative relationship between the amount of reactants used and the amount of products formed. So sabi natin, kung gaano karami yung mass ng mga reactants, dapat ganun din yung products na makukuha natin at the end of the reaction. So the law of conservation of mass states that the matter is neither created nor destroyed in a chemical reaction. It also means that the mass of the reactants must always equal the mass of the products. In using balance equation, we have to remember that the coefficients of reactants and products can represent the number of atoms as well as the number of moles that reacted. Moles do not directly tell us the mass of the reactants. However, remember that the number of moles can be converted into grams. So pag nag-compute na tayo sa ating stoichiometry, ay malalaman natin yung relationship ng moles sa coefficient at saka sa mass. Now look at this relationship from a balance equation. So for example, we have iron and oxygen reacting. So this should be a combination reaction that will produce iron oxide, iron 3 oxide. If we were going to look at the skeleton equation, we will have 4 iron reacting with 3 oxygen, producing 2 iron oxide. So that is also a balance equation. Same as saying that 4 atoms of iron will react with 3 molecules of oxygen and will produce 2 formula units of iron oxide. Also, same as saying that we have 4 moles of iron reacting with 3 moles of oxygen will produce 2 moles of iron oxide. So if we have a mass, 223.4 grams of iron reacting with 96.0 grams of oxygen, it will give us 319.4 grams of iron oxide. So if you look at the reactant side, the iron and oxygen, you add up the mass of these two reactants, you will arrive with the amount of mass of the product. So, equal yung kanilang mass. So, yun yung tinatawag natin kanina sa law of conservation of mass. So, whatever reacts will produce the same amount of or the same mass. Yung mga coefficient natin sa balance equation, ginagamit natin siya para kumuha ng mole ratio. So, mole ratios is a ratio between the number of moles of any two substances in a chemical reaction, in a balanced chemical reaction. So here, we can see the balance equation. 2 hydrogen peroxide will produce 1 mole of oxygen and 2 moles of water. So, tingnan natin yung mga coefficient natin dito. Yan. So, pagkuha ng mole ratio, sabi natin, it is a ratio between the number of moles of any two substances. For example, we want to get the ratio of oxygen to water. Okay? So, 1 mole of oxygen is equivalent to 2 moles of water. Also, we can say 2 moles of hydrogen peroxide is equivalent to 1 mole of oxygen. Hydrogen peroxide pala siya. So, yun. Yung relationship nila, yung mole relationship or mole ratio, ginagamit natin itong mga coefficient na ito. Okay? So, we have to study So in the stoichiometric calculations of mole to mole conversions, we have to first determine the number of moles produced from your reaction, and we have to make sure that we have a balanced equation. So pag tinignan natin yung, halimbawa, we're given a skeleton equation of a reaction. So ang una natin titingnan, tama ba or balance ba yung ating equation? Next is, after you write the balance equation, you need to identify the substance you know and the one you need to determine. And you will use the mole ratios to determine the substance that you need to find. So we have here an example. A vigorous reaction between potassium and water produces hydrogen gas and potassium hydroxide. So first, of course, we have to write the balance equation. So this is the balance equation. 2 potassium reacts with 2 water and produces 2 potassium hydroxide and 1 hydrogen gas, or 1 mole of hydrogen gas. So the question goes like this: how many moles of hydrogens are produced if 0.0400 moles of potassiums are used? So ang tinatanong natin, gaano karaming hydrogen ang mapoproduce kung ang ginamit natin na potassium ay 0.0400 moles. Okay? So we have to know the moles of known times the mole ratio. So para malaman natin yung moles of unknown. Ang unknown natin dito ay si hydrogen gas. Yun ang hindi natin alam. Pero ang alam natin dito ay the number of moles of potassium. Ito. Alam natin yun. Which is 0.0400. Okay? Ang alam natin ay moles of known. So, ang moles of known natin ay we have 0.0400 moles of potassium times the mole ratio of potassium. So, sabi natin dito, ang dalawang potassium ay may mole ratio na 2 potassium, 2 moles of potassium is equivalent to 1 mole of gas. 1 mole of H2 gas. So, ganyan siya. Okay? Para makancel natin itong mole K, kasi magkamukha sila, mole K. So, we can do the multiplication of 0.04 times 1 is 0.04 divided by 2, we will get 0.0200 mole of hydrogen. So, kailangan natin tandaan sa dimensional analysis. Okay? Pag naghahanap tayo ng unknown, lagi natin nilalagay yung unknown dun sa numerator ng ratio. Nandito yung unknown. Tapos yung mga quantities ng known, alam natin, nilalagay natin dito. Tapos sa baba yung known. Kasi ang gusto lang naman natin makita itong unknown, di ba? So, once we do the dimensional analysis, nagka-cancel out lang to. So, it will be the unknown that will be left. So, kine-carry over natin siya as parang units. So, since yun yung gusto nating malaman, number of unknown. So, parang gano'n. Kanina, we have 0.0400 mole ng potassium. Tapos, kinuha natin yung mole relationship ng potassium tsaka ng hydrogen gas. So, yung hydrogen gas nilagay natin dito, yung potassium nilagay natin dito. Pwede kasi itong magkapalitan. Pero, depende nga kung ano yung gusto nating ma-achieve. So, in this case, ang gusto nating ma-achieve or matira sa kanila ay itong hydrogen gas. So, kaya ganito yung ating mole ratio. So, kanina nakita natin na 2 moles of potassium is equivalent to 1 mole of hydrogen. So, nag-cancel out yung ating mole. Kaya ang naging sagot natin ay 0.0200 mole ng natira, which is H2 or hydrogen gas. So let us look at this example of the combustion of ammonia, NH3, to produce nitrogen gas and water. So as you can see, the reaction is not balanced, or the equation is not balanced. So we have to put coefficient to make sure that our reaction is a balanced reaction. So we're going to put 4 here, and then 3, 2 nitrogen, and 6 water. So the question is, what if 11 moles of NH3 is used? How many oxygen or moles of oxygen will be used in the reaction? So ang known natin ay 11 moles of NH3, and we have to find a mole ratio that will give us the answer to our question. So again, look at the mole ratio of ammonia and water and oxygen. So ang desired natin ay number of moles of oxygen. So lagyan natin si oxygen dito, and we have 3 moles of oxygen, and it is equal or equivalent to 4 moles of ammonia. Para itong dalawa, yan, magka-cancel out sila. So we will be left with the moles of oxygen, which is our desired answer, mole O2. So doing the math using your scientific calculator, we will have 11 times 3 divided by 4 is equivalent to 8.25 mole. So by the way, when we say mole, ang ibig sabihin niyan ay ito, moles. Whether it's plural or singular, ito yung ginagamit natin sa dimensional analysis para mas maikse. So next naman natin ay yung stoichiometric calculations ng mole to mass. Now you're supposed to know the number of moles of a reactant or product and want to calculate the mass of another product or reactant. So ganun pa rin, gagamitin pa rin natin yung mole to mole ratio or conversion, and then gagamit naman tayo ng molar mass para malaman natin kung gaano karami in grams yung ating magiging sagot sa question sa ating stoichiometric problem. So for example, we have a glucose, okay, that is being produced when 24 mole of carbon dioxide reacts in excess water. So, ang tanong dito, gaano kadami yung glucose na mapoproduce? Hindi mole. Hindi lang tayo hinto sa mole. Of course, we have to start with a balanced reaction. So, this is basically photosynthesis. So, ang sabi sa problem kanina ay 24 moles of carbon dioxide will react with water to produce glucose. So, ang tanong natin, gaano karaming glucose in grams? Okay? So, we will begin with the mole-to-mole computation of mole-to-mole ratio. So, sabi sa problem, 24 moles of carbon dioxide will react with water. So, kunin natin yung mole-to-mole ratio ng carbon dioxide at ng glucose. Kasi ito yung hinahanap natin, yung glucose. We'll have C6H12O6 here, and of course, mole ng carbon dioxide. Mole. Para mamaya ito, pwede natin i-cancel to sa baba. Okay, so ilang moles ang equivalent ng carbon dioxide sa isang glucose? So we have 6 mole of carbon dioxide is equal to 1 mole of C6H12O6 or glucose. So doing the math, we will have 4.00 mole of C6H12O6. Now, we're not yet done because we need to find the grams. So we will use this one. 4.00 mole of C6H12O6 is equivalent to ano nga yung ratio ang ating gagamitin. Hindi na natin gagamitin ng mole ratio. We will use the mole mass ratio. So we will use a ratio that will allow us to cancel this one out. Kasi ang desired natin ay grams of C6H12O6. So, ang ilalagay natin dito sa baba ay mole C6H12O6 para makancel natin siya mamaya. So, paano na ang gagawin natin? So, we will have to use the formula mass of C6H12O6. If you could remember how to compute for formula mass, kasi ang 1 mole ng C6H12O6 ay laging equivalent sa formula mass ng compound na ito. So, we will have 1 mole of C6H12O6 equivalent to the number of grams or the formula mass of C6H12O6. And calculating the formula mass of C6H12O6, we will have 180.18. So, paano ulit nakuha tong 180.18? So, let us recall how to get the formula mass of a compound. Of course, we have to check first the atomic mass of each atom. We have carbon, 12.01. Hydrogen is 1.01 and oxygen is 16. So, doing what we used to do, we have 6 times 12.01 dahil 6 siya. This is 72.06 carbon. Then for hydrogen, we have 12 hydrogen times 1.01 kanyang atomic mass. We have 12.12 grams of hydrogen. And then for oxygen, we have 6 oxygen times 16.00, that is 96.0 oxygen for a total of 180.18. So, balik tayo sa ating conversion ng mole to mass. We have 4 moles of C6H12O6 times 180.18 grams of C6H12O6 over 1 mole of C6H12O6. So, doing the math, we will arrive at the answer 721 grams of C6H12O6. Okay? So, our last stoichiometric calculation is what we call the mass-to-mass conversion. So, kanina, mole to mole. Sumunod naman ay mole to mass. Ngayon naman is mass to mass. Parang, given ka ng mass, kukonvert mo siya sa mole, kukonvert mo siya sa mole ng unknown, and then kukonvert mo yung mole ng unknown sa grams ng unknown. So, parang umikot tayo. Okay? So, para mas maintindihan natin to, we will have an example. How many grams of sodium hydroxide are needed to completely react with 50 grams of sulfuric acid to form sodium sulfate and water? So, this is our balance equation. Have to remember to look always at the balance equation. So, we have the known figure here. We have 50 grams of sulfuric acid. First, let us look at the mass to mole ratio. Kasi gusto natin i-convert muna si sulfuric acid into the number of moles. So, we will have here the molar mass of sulfuric acid, which is 98.09 grams sulfuric acid. So, compute nyo na lang kung ano yung kanyang formula mass. Okay? And this is always equal to 1 mole of H2SO4. So, cancel natin to. Cancel natin to. We will be left with mole of H2 SO4. And the answer is 0.510 mole H2SO4. Now, we have now a mole. Pwede na natin gamitin yung mole-to-mole conversion. 0.510 mole of H2SO4. Ang gusto nating ilagay dito ay mole ratio ng sulfuric acid at ng sodium hydroxide. Okay? Mole ratio. So, tingnan natin yung ating balance equation. Ano ang mole ratio ng sulfuric acid at ng sodium hydroxide? So, ang isang mole ng sulfuric acid ay magre-react sa 2 mole ng sodium hydroxide. So, 1 mole of sulfuric acid, H2SO4, will react to 2 moles of sodium hydroxide. Okay, so we cancel mole H2SO4 and mole H2SO4 here. So we'll be left with the mole of sodium hydroxide. So the answer is 1.02 mole NaOH. Okay. So are we done? Not yet. We're not yet done. Ko-convert naman natin ngayon itong mole na ito ng NaOH na nagamit into grams. Kasi grams yung ating hinahanap. So we have 1.02 mole NaOH times, this time, ang gagawin naman natin, pabalik. From mole NaOH to grams. Kasi mass to mass yung ating conversion na ginagawa. So 1 mole of NaOH is equivalent to the formula mass or molar mass of NaOH, which is 40 grams. So we cancel mole NaOH. So we'll be left with grams of NaOH. So doing the math, 1.02 mole times 40.00 is equal to 40.8 grams. So that is our final answer. 40.8 grams of sodium hydroxide will react with 50 grams of sulfuric acid. So try this exercise. How many grams of hydrogen gas are needed to react completely with 54 grams of oxygen gas, given the following unbalanced chemical reaction? So we have an unbalanced chemical reaction. Of course, you have to balance this first. And then you may use this information, the molar mass for oxygen, which is 32 grams. And for hydrogen gas, we have 2.02 grams. So I will be giving you 10 minutes to answer this exercise. Okay, so let us answer the exercise. So again, we would like to find the number of grams of hydrogen gas that are needed to react completely with 54 grams of oxygen gas, given the following unbalanced chemical equation or reaction. So we have to balance first the chemical reaction. So we have to put 2 here and 2 here. So we will have a balanced equation. Okay, first thing is we have to identify the given, which is 54.0 grams of oxygen. And we want to convert this one into moles of oxygen. So, given tayo ng molar mass, okay, we have 32.0 grams of oxygen is equivalent to 1 mole of oxygen. So, we have 54 times 1 mole. So, cancel na natin ito nasa ilalim. Divided by 32. So, we have 1.6875 mole of oxygen. So, next is we have to get the mole ratio of oxygen and hydrogen gas using this coefficient. So, we have 1.6875 mole of oxygen times 1 mole of oxygen is equivalent to 2 moles of hydrogen gas. So we cancel this one, rather the entire mole O2. So 16875 times 2 is equal to 3.375 mole of H2. So we now have mole of H2. So we want grams of H2. So we will have a mole to mass conversion, 3.375 mole of H2 times 1 mole of H2 is equivalent to the molar mass, which is 2.02 grams H2. So, cancel natin yung mole H2. We will have 3.75 times 2.02 is equivalent to 6.8175 grams of H2. Okay? So, that's it for today. I hope you've learned something new, and we will continue our discussion with the limiting reagent and the theoretical and actual yield. So that will be our last topic for the first quarter. Or probably we will go back to molecular structure and discuss biological molecules, which is konti lang naman yun. So, konting listing lang ng iba't ibang biological molecules depende sa kanilang functional groups na naka-attach na molecules na yun. So, again, thank you for joining me in this session. Have a great day. Goodbye, everyone.